Good day everyone, my name is Tanika Mullings and today I will be presenting Unit 17, Human Immunity. This presentation is divided into three sections as displayed here. In section 1 we'll be going through the understanding of non-specific defense against the diseases. For section 2 we'll also discuss the self-recognition and tolerance, description of two specific immune system disorder. And section 3 will go through the immune responses to vaccination and the benefits of vaccination. Now let's get into it. Section 1, it says non-specific defense destroy various bacterial or viral invaders or cellular debris resulting from tissue damage without specific recognition of which bacterium or viral invaders. And there are different types of diseases that may cause illness in the body, which are virus, bacteria, fungi, and parasite. And bear in mind that the immune system protects our bodies from outside invaders, such as what I've mentioned. We may ask ourselves, how do germs spread? The answer is quite simple. Germs can be spread through various channels, such as sneezing, coughing, rubbing of the eyes, and with these it can also be transferred to person to person. But with a simple wash of the hands, this can get rid of any form of diseases and prevent any form of infection from being spread. Now most germs that makes us ill are normally transferred through direct or indirect contact, and for indirect contact it's spread when an infectious person sneezes or coughs, and it sends infectious droplets into the air, or when it lands on the surface and a healthy person may touch that surface and gets into contact with it, that person may become ill. And for direct contact, it is spread when a disease-causing microorganism is passed from a person to a healthy person through physical contact, through blood or bodily fluids, such as touching, kissing, sexual contact, or oral secretions. Our skin is the largest organ of the body, which is divided into three layers: the epidermis, dermis, and the hypodermis. The epidermis is the outermost layer, the epidermis, and it acts as the first line of defense against external threats, and it consists mainly of dead cells and provide waterproof and protection against UV radiation. For the dermis section, it's beneath the epidermis. It's a thicker layer containing blood vessel, nerves, sweat glands, and hair follicles. For the hypodermis, it is the innermost layer, and it's composed of fat and connective tissue. And it serves as an insulation, energy storage, and padding while connecting to the skin, underlayer, muscle, and bones. Our body has physical and chemical barriers, some of which we are born with. For example, we have the skin, we have fatty acid, we also have mucus and cilia. For our eyelashes and lips, those operate as dust catcher. Those protect our eyes from debris that may impede sight. And for the mucous membrane, it safeguards the inner part of our body, that body exposed to air. And they are rich with mucus glands that secrete mucus, keeping the membrane moist. Example, our lips and our mouths. For this slide, we will show you how the skin operates when it gets injured. This is called the inflammation process, as well as the second line of defense. Whenever the skin gets pricked by a pin or whatever it may be, the first process, it shows where chemical signals, it sends chemical signals such as histamine, and for the second step, the skin starts swelling. The skin starts to swell, which is dilation and increased leakiness of local blood vessels. And for the third step and final step is the phagocytes and macrophages, or consume bacteria and cell debris tissue starting. Section 2, we're going to speak on antigens and cytokines. Antigens are substance proteins found on the cell's surface, while cytokines are small proteins that control growth and activity of other immune system cells and blood cells. The continuation of the second line of defense. Together, white blood cells form a dynamic defense system, helping to safeguard our body against a wide range of threats. The diagram shows a list of white blood cells that protects our body from infections. We have the neutrophils, which kills bacteria, fungi, and foreign debris. Monocyte cleans up damaged cells, while the eosinophils kills parasite cancer cells and invading allergic response. Lymphocytes help fight viruses and make antibodies, and basophils involving allergic response. Our body consists of different classes of immunoglobulins. What are immunoglobulins, you may ask? This is an antibody, or immunoglobulins are antibodies or glycoprotein molecules preceded by plasma cells or white blood cells. They act as a crucial part of the immune response that identify and bend to specific antigens, example, bacteria or viruses. The 5 primary classes of immunoglobulins are IgG, IgM, IgA, and IgD. For the IgEs, it have epsilon chains and are involved in allergies. For the IgDs, they have delta chains and are antigens, receptors, and activated by B cells. Self-recognition and tolerance. The immune system can distinguish between cells, which is self, and foreign materials, which are non-self, and react to foreign objects with an immune response that eliminates the intruding bacteria. And as you can see, for the identifying cells, this is an example of self-maker, as well as for identifying non-self, which is the antigen sector. The antigen is a molecule that the immune system recognizes and is known as foreign, which is non-self, and as a threat. There are different types of hypersensitive reaction, which you have the type 1, type 2, type 3, and type 4. Hypersensitivity is the exaggerated immune response protecting the body from foreign bodies known as antigens. For the type 1, you have the IgEs. For the type 1, you have the IgEs, as we have mentioned before. This gets resolved within an hour. And for the type 2 is the IgG or IgM. Resolution is in an hour to days. And for type 2, it resolves within 1 to 3 weeks. And for the type 4, days to weeks. This slide will speak of autoimmune diseases. And we list a few here. So we have the lupus, asthma, we have arthritis, type 2 diabetes, of which few of these are hereditary. For example, type 1 diabetes, that's hereditary, as well as arthritis. Organ transplant. You may ask, what is organ transplant? It is the replacement of dysfunctional tissue with a healthy tissue from a living or a person who just deceased. The grafted tissue expresses antigens that's not present in the host, identified as foreign. The immune system reacts as the donor tissue is an infected microbe and attacked the graft. And as we've looked at slides previously, it shows that the immune system recognizes antigen and surface cells as foreign or self. There are a few types of transplant rejection as displayed here. We have the hyperactive, the acute, chronic, and these happens on the onset, which is hyperactive, is immediate. This happens when a patient is in surgery. Hyperacute, the onset is immediate. This happens if and when the patient is undergoing surgery, if there's any reaction. This causes from a mismatch of incompatibility, which is very rare. As the chronic, it takes months to years and weeks to months for acute. Adaptive immunity, we're now in section 3. Adaptive immunity, it is basically the immunity that involves specific immune cells and antibodies to attack and destroy foreign invaders. Active immunity results from exposure to a disease organism which activates the immune system producing antibodies to the illness. Active immunity is required through natural or vaccine-induced immunity. Its exposure to pathogens such as common cold develop natural active immunity. There are 2 types, which is 3 types: naturally, artificially, which naturally is passive immunity, is when antibodies are passed from person to person, example unborn child, and it's protected for up to 6 months, while artificial immunity is gained through antigens introduced through vaccines, causing reaction that stimulates the production of antibodies and memory cells. For this slide, we'll be speaking of vaccine. What is vaccination? Vaccination is a safe and simple and effective way to protect you against harmful diseases before you come in contact with them. The primary immune response occurs when you are infected with a pathogen for the first time, and the lymphocytes identify the antigen, and it takes time for the plasma cells to produce an appropriate antibody. If the body re-encounters the same pathogen, the body will react with a secondary response faster than the primary response. The memory cells can quickly recognize the pathogens and produce the required antibodies to find the antigens before occurrence of the symptoms. For this slide, we will be speaking of the cases of measles in the UK from 1940 to 1945. This chart, it reflects the number of measles cases in the United Kingdom as stated from 1940 and 1995, were hundreds of thousands of measles yearly before a vaccine existed. In 1967, the year before vaccination was introduced, there were 460,407 suspected measles cases in the UK, where 99 people died and more than 2 persons per year died from measles from 1999 to 2017. Also, between 1995 and 1999, a total of 10 persons died aged 10 and over. The combined measles, mumps, rubella, which is MMR, vaccine was introduced in the UK in 1988 at the end of the year, bringing down the figure for suspected cases a year with 1 or 2 deaths. Also, number of children receiving the MMR vaccine declined in the 2000s. What's herd immunity? Simple. Herd immunity occurs when a large portion of community becomes immune to a disease. It also protects vulnerable persons, newborn and elderly, who are too ill without requiring them to come in contact with the pathogen either naturally or artificially. Herd immunity is based on the idea that more individuals vaccinated, the less likely the disease is to spread. Several problems can occur during an outbreak before a population reaches a high immunity level to achieve herd immunity. Children in the UK did receive vaccination program, which includes ages 11 plus vaccination, covering diseases including mumps, rubella, influenza, and measles. There are different factors that affect the taking up of vaccine, such as listed you have distrust, low confidence, and some access barriers, inconvenience, and social demographic. Research stated that vaccine uptake has been low in certain regions with more minority ethnic group population. Thank you so much for watching, and I hope you had learned something today.